Hi guys, so today we're going to be graphing and solving quadratic inequalities. If you're able to graph a regular quadratic function, then you're pretty good to go, okay? So we're going to do a couple of examples of graphing. I'll do one example, you'll do check your progress, and then we'll go from there, okay? So the first thing we're going to do is we're just going to graph our quadratic inequality, okay? And so what we're going to do is we're going to start off with it just like we would graph our quadratic function. So I'm going to start with the axis of symmetry since this is in standard form. We're going to do x equals negative b over 2a. So that will be x equals negative 6 over 2 times a is negative 1. Okay. This gives me 6 over negative 2, which is negative 3. And then here, I'm going to make my table. So starting with negative 3, since that's my vertex now. And we're going to keep going. Okay, so here there isn't as much room to show my work. Okay, so I'm just going to do it for the first one, and then I will talk us through the other ones. Okay, so negative 3 squared is 9, so negative 9. Okay, negative 6 times negative 3 is a positive 18, and then minus 7. So negative 9 plus 18 minus 7. And that gives us 2. Okay. So our first point is at 3, 2, and negative 3, 2, and that is our vertex. Okay. And then I'm going to try some on each side. So let's do negative 2, negative 1, and 0. Okay. So plugging in, negative 2 squared is 4, so then this will be negative 4. Negative 6 times negative 2 is positive 12, and then minus 7, this gives me 1. Okay. Plugging in negative 1 squared is 1, and then the negative in front would make it a negative 1. Negative 6 times negative 1 will be positive 6, and then minus 7, this will give us negative 2. 0, okay, so negative 0 squared is just 0, minus 6 times 0 is still 0, minus 7, that gives us negative 7, and after that, it won't fit. Okay. So I'm going to graph negative 3, 2 first. 1, 2, 3, negative 3, 2. Okay. So again, this is my axis of symmetry, right? And so this will help me to mirror it over. Okay. Then I have negative 2, 1, and then mirror it over here. Then I have negative 1, negative 2, and then I'm going to mirror it over here. And then last is 0, negative 7, 1, 2, 3, 4, 5, 6, 7. And then I'm going to mirror over here. And I'm going to graph it. Okay. Because no equal to, that means this is going to be dotted. So as best as I can, I'm going to dot it here. Okay. Okay. And then I'm going to do my test point, which is going to be 0, 0. Right. So is 0 greater than negative 0 squared minus 6 times 0 minus 7? This gives me negative 7. Is 0 greater than negative 7? Yes, it is. So what that means is I'm going to shade where 0, 0 is. And so in this case, that's going to be outside of that little U shape here. Okay, and there you go. Okay, so why don't you try CYP1A, and then once you're done, come check your answer. Okay, this is what you should have gotten starting with your axis of symmetry at negative 1. X equals negative 1. Your vertex is at negative 1, 3, and then on one side is 0, 4, 1, 7, and 2, 12 doesn't fit. Okay, it should be a solid line, not dotted, because it is equal to. And then when you test the point, you would realize here that we are shading below or outside of that quadratic. Okay, so the next one here is x squared plus 2x minus 3 is greater than 0. Okay, so what we're going to do is we're going to just graph it. So again, I'm going to start with my axis of symmetry. So x equals negative b, so negative 2 over 2a, 2 times 1. This gives me negative 2 over 2, which is negative 1. So that gives me my axis of symmetry. And then my vertex now. Okay. Then negative 1 squared is 1. 2 times negative 1 is negative 2, and then minus 3. So 1 minus 2 minus 3 is negative 4. That's my vertex. I'm plugging in 0 here. 0 squared is 0. 2 times 0 is 0. So 0 plus 0 minus 3 is negative 3. Okay. Then I'm going to do 1. Right? 1 squared is 1. 2 times 1 is 2 minus 3. So 1 plus 2 minus 3. That gives me 0 here. Okay. Then I'm going to plug in 2. So 2 squared is 4. Then 2 times 2 is 4. So 4 plus 4 minus 3. And that gives me 5. Okay. And then let's do 3. So 3 squared is 9. 2 times 3 is 6. And then minus 3. And this gives me 12. Okay. So that one doesn't fit. Okay. So now let's graph. So starting with my vertex at negative 1, negative 4. 1, 2, 3, 4. That's here. Let me draw my axis of symmetry to help me mirror it over. Okay. 0, negative 3 is here. Mirror it over here. 1, 0 is here. Mirror it over here. And then 2, 5, 1, 2, 3, 4, 5 is here. 1, 2, 3, 1, 2, mirror over here. Now I'm going to connect. Okay. So here, if you look, I went for the parts where it's greater than 0. Okay. So here is where it is 0. Okay. So the parts greater than 0 would be this and this. Everything from this side here and this side here. And so what that means, it will be all the ones where x is less than 1, 2, 3, negative 3, and, or, the parts where it is greater than 1. Okay? And there you go. Or you can write it as negative infinity to negative 3, and the parts from 1 to infinity. Okay. Both are fine. The top one is in inequality notation, and the bottom one is in interval. Okay, so why don't you try 2b, right, and then come check your answer when you're done. Okay, here's your answer. X is less than or equal to negative 5, or x is greater than or equal to 7. This is an interval notation. I hope for this one, this was frustrating to graph, because it doesn't quite fit in your graph very well. But however, even if you didn't graph it, you can probably see it once you did your table. But the graph is a great way to see it visually, right? But it does have its flaws, especially if we're graphing by hand. Which is why later on in this lesson, we're also going to learn how to do it algebraically. So we don't have to deal with some kind of graphs that kind of are like off the charts here. Okay. So we're going to do this next one. It's going to be an alternative to example 3. So I kind of changed the question a little to be x squared minus 6x minus 7 is less than 0. Okay. So again, I'm going to start with my axis of symmetry. So x equals negative b, so negative 6 over 2 times a. That would be 6 over 2, which is 3. So then let's plug stuff in. So it's going to be 3, 4, 5, 6. And then we'll see how many we can fit. Okay, so plugging in 3. 3 squared is 9. Negative 6 times 3 is negative 18, and then minus 7 is negative 16. Okay, so negative 16. Okay. Then I'm going to plug in 4, so 4 squared is 16, negative 6 times 4 is negative 24, and then minus 7, negative 15. Okay. So then I'm plugging in 5, 5 squared is 25, negative 6 times 5 is negative 30, minus 7. Is negative 12. Right. Plugging in 6. 6 squared is 36. Negative 6 times 6 is negative 36. And then minus 7. So this gives us negative 7. So we're finally officially on the graph unless we change our scale. Okay, then 7. 7 squared is 49. Negative 6 times 7 is negative 42. And then minus 7, this gives us 0. Okay. So we can probably see the pattern here of where it'll be, but let's just keep going here. So 8. 8 squared is 64. Negative 6 times 8 is negative 48. And then minus 7, and this gives me 9. Okay, so then let's stop here. Okay, what I'm going to do is I'm going to make each one 2. Okay, so for the x's, I'll leave it as 1, so 10 to negative 10. But then for the y's, I'm going to make each one 2, so negative 22, 20. So 3, negative 16, so 1, 2, 3, 4, 5, 6, 7, 8 then. This would be where negative 16 is. I'm going to draw my axis of symmetry to help me mirror it. Okay. 4, negative 15 would be halfway here. Then 5, negative 12, so then be 1, 2, 3, 4, 5, 6 here. Okay, 6, negative 7 would be 1, 2, 3, around here. 7, 0 would be here, and then 8, 9, 1, 2, 3, 4, and then it'll be 9. Okay. So then let me mirror these over. Okay. I'm going to connect my dots for now. Okay. And then here, so this time we want the x values that are less than 0, so that means they will be below the x-axis. And so the parts that are less than 0 is here to here. So this is negative 1. Oh, sorry. Not equal to, because not equal to. And then this is 1, 2, 3, 4, 5, 6, 7, and 7. So it's the x values between negative 1 and 7, but not including those. Okay. And so here you go. Right. What I don't like about the book is that it claims that we're solving it by graphing, but really they're doing some algebra stuff and then just using the graph to check. Okay. But this is really what it looks like to solve by graphing. You should graph it, and then based on what the graph looks like, then you get your answer. Okay. So here, you're going to do check your understanding, but I changed it a bit. Okay. So you're going to be doing negative x squared plus 5x plus 6 less than or equal to 0. Tell me which x values fit with that. Okay, this is your answer that you should have gotten. So starting with x's of symmetry, negative b, so negative 5 over 2 times 1. That gives you negative 5 halves, or negative 2.5. Plug it in and you'll get negative 12 and 3/4. Right, so it doesn't fit. So the reason why it looks so weird is because I altered the scale. While each of these are 1, each one on the y is 2, right? So it's kind of a skewed or altered graph, although it is accurate, it's just a little bit misleading. Okay, then I just plugged a couple of values in. I did negative 2, negative 1, 0, 1. Okay, because after this one, you don't really have to deal with fractions as much. So you can choose values that make it a little bit easier for you. Okay, then I mirrored it. And then, so since I want the values that are less than or equal to 0, that'd be here. Okay, and that will be from here to here, and so that's between negative 5 to negative 1. Okay, so hopefully what some of these help you to realize, like whenever you have the fraction ones or whenever they don't fit in a graph, is while the graph is great visually, it's not great in practice just because of how skewed it looks and how long it could take, right? And so that will eventually take us to how to solve it algebraically. But before we get there, we're going to move to example 4. Okay, so let's get started. So here with example 4, our real world example. So the height of a punted football can be modeled by the function h of x equals negative 4.9 x squared plus 20x plus 1, where the height, h of x, is given in meters and the time here is in seconds. Here we want to know at what time in its flight is the ball within 5 meters of the ground. So what that means is we know that the height is 5. So I'm going to plug that in here, 5. Okay. So 5. Within that, so that means less than or equal to negative 4.9 x squared plus 20x plus 1. you'll see that the book flips it around, so that way it's this way. Oh, sorry. Yep. All right, so this is less than that. It's less than or equal to 5. All right. So what we're going to do is we're going to move this 5 over by subtracting it, and that will give us negative 4.9x squared plus 20x. So minus 5, 1 minus 5 is negative 4. Okay. And then here, for the word problems, I'm totally okay if you just graph it using Desmos or a graphing calculator. Okay, and then so here it is graphed. And so within that, we can see here the ball is within 5 meters of the ground here when its x is less than or equal to 0.21 or x is greater than 3.87. And so thus the ball is within 5 meters of the ground for the first 0.21 seconds of its flight. So here to here. And then again after 3.87 seconds until the ball hits the ground at 4.13 seconds. Okay. And so there you go. Okay, so then I'm going to have you try CYP4, and then once you're done, come check your answer. Okay, this is what you should have gotten for 4. Since we want it to be at least 7 meters above the ground, that's why the height is going to be greater than or equal to 7. Subtract the 7 on both sides, that gives me my negative 6. And then when I graph this, okay, the parts that are above the x-axis are going to be between 0.33 and 3.76, which means the ball is at least 7 meters above the ground from about 0.33 seconds of its flight to 3.76 seconds. Okay. So now for the next couple that we're going to do, I'm going to do example 5 and a changed example 3 okay, to show you how we would solve this algebraically. Okay. So we're going to start off with example 5 of x squared plus x is greater than 6. Okay. So what I'm going to do first is I'm going to subtract 6 on both sides. So that way we have it being 0 on the other side. So x squared plus x minus 6 greater than 0. Okay. Then what I'm going to do is I'm going to solve our quadratic just like we do with our other ways, right? So you can solve it by factoring, quadratic formula, completing the square. I'm great at factoring, and this is factorable, so I'm going to factor it. It becomes x plus 3 and x minus 2. Okay. And so with that, my x values would be negative 3 and 2. Okay. What I'm going to do now is I'm going to place it on a number line. Here's negative 3 and here's 2. And I'm going to test numbers. Okay. So let's say I'm testing negative 5. Okay. So negative 5, let's say I'm testing negative 5. Right. So negative 5 plus 3 is a negative number. Okay. Negative 5 minus 2 is also a negative number. A negative times a negative is a positive. Okay. Then I'm going to test 0 because that's in between negative 3 and 2. Okay. 0 plus 3 is positive. 0 minus 2 is negative. So positive times a negative overall is going to be negative. Okay. Then I'm going to test 3. 3 plus 3 is positive. 3 minus 2 is also positive. Positive times a positive is positive. Okay. So which parts are greater than 0? The positive parts. So that means it's from negative infinity to negative 3, as well as from 2 to infinity, or if you choose to write it in as an inequality, that means x less than negative 3, or x greater than 2. And there you have example 5. Okay. So either way is acceptable. Okay. So let me do the next one here. Right. So I'm just going to rewrite this one as 3x squared minus 7x minus 1. If 0 is greater than that, that means that is less than or equal to 0. Okay. This one is not factorable, so I'm going to solve it through another method. And so I'm going to use the quadratic formula. So x equals negative b, so negative 7, plus or minus square root b squared, negative 7 squared, minus 4 times a, which is 3, times c, which is negative 1, right? All over 2 times a. Okay? This gives me 7 plus or minus negative 7 squared is 49. Right? Negative 4 times 3 is negative 12, times negative 1 is a positive 12. All over 2 times 3 is 6. Right? 49 plus 12 is 61. So this is 7 plus or minus square root of 61 over 6. Just so I know what this is approximately, okay, 7 plus square root of 61 divided by 6 is about 2.5. Right, so I'm going to say approximately 2.5. Okay. And then 7 minus the square root of 61 divided by 6 is approximately negative 0.1. Okay. And then now I'm going to test out my different points. Okay. So plugging in here, I'm going to do a negative 1. Okay. So so negative 1 squared is 1 times 3 is 3. 3, and then negative 7 times negative 1 is a positive 7, so 3 plus 7 minus 1. This gives me a positive 9. Right? Then I'm going to test 0. So 0 squared is 0, times 3 is 0. Negative 7 times 0 is also 0, so 0 minus 0 is still 0, minus 1. This gives me a negative. Okay? And then I'm going to test 3 here. Okay? So 3 squared is 9, times 3 is 27. Negative 7 times 3 is 21. And then minus 1. This gives me a positive. So here I want the ones that are less than or equal to 0. So that's going to be between here and here. So that means it's between 7 minus square root of 61 over 6 and 7 plus square root of 61 over 6. Because this is the 7 plus square root of 61 over 6. This is the 7 minus square root of 61 over 6. Okay. And so now you're going to try check your progress 5A here. And then here there's a changed check your progress. I changed the 3A to be this. And then come check your answer. Okay, so for 5A, I solved by factoring. I factored it, so then I got negative 2 and negative 3. Then when I tested the points, this resulted in a positive number, this is a negative, and this resulted in a positive number. And since I want it to be less than 0, that would be between here and here, and so that's why it's the values between negative 3 and negative 2. For 3A, this one wasn't factorable, so I solved by doing the quadratic formula, and that gave me negative 5 plus square root of 73 over 4. That's approximately 0.9. And then I did negative 5 minus square root of 73 over 4. That's approximately negative 3.4. Okay. When I tested a point on this side, it was positive. When I tested something within here, it was negative. And when I tested something here, it was positive. And so since I want the part here was 0 greater than this, so that means this is less than 0. Then the parts that were negative was here, so that was between these two. Okay. So that's it for today. Have a great rest of the day. Bye, guys.